Hey guys, welcome to this video. We're going to look at basically sketching inequations graphically, putting on a Cartesian plane and seeing what that looks like. So we have, I'm going to write an example here where we have 2x plus 3y is less than 6. And for convenience sake, I'm going to rearrange this so we follow the linear equation rule, y equals mx plus c. So I'm going to move the 2x to the right hand side, so 3y is less than negative 2x plus 6, and then divide both sides by 3. So we've got y is less than minus 2/3 of x plus 2. So we know from this that the y-intercept is at 2 and our gradient is going down at a relatively shallow steepness of 2/3. All right. Now, there is the intercept method because we are just sketching. So we find what our x-intercept is when y is made 0. So if we substitute it to this equation, 2x plus 0 is less than 6. That means x is going to be less than 3. So here we have our x-intercept, and here we have our y-intercept. Okay, so if we were to sketch this, we have 2 for our y, and we have 3 as our x. Okay, and so the one thing that I want you to take note of is we do have these exclusive symbols. Okay, remember that we had an open circle, and then we have these two symbols which are inclusive, which requires a solid dot, okay, a closed circle. But we're not working on a number line, we're working on a Cartesian plane. So when we're working with lines, okay, straight line graphs, the straight line is going to be a dash for the exclusive and a solid line for the inclusive. So in this case here, we're going to, because it is a exclusive symbol, we're going to put a dash where we would normally have a solid straight line. So that is the straight line graph for that particular linear equation. But because we have a inequality symbol, we're going to actually exclude any value that is along that line. And because it is less than, okay, we are going to shade everything below because it is less than everything under there. So y is all the values that are less than and below that line, not including any values on that line. Okay. If we had, and let's see if I can just backtrack all the way, if we had another scenario where we changed it to a, let's say, greater or equal to, and this is all that is different, okay? We still have the same equation, but this time we have a solid line going all the way through. And because it's greater, we're going to shade everything that is above the line. So now y are all the values and the region that is above and including the line itself. Okay, so hopefully that helps you with sketching graphs and the regions of inequations. Let me know if you have any questions. We're going to finish off the chapter with solving simultaneous linear equations through just problem solving. All right, see you later.